Hello everyone, this is NK Pandey. Today I am going to share some interview questions on mass transfer operations. I hope the questions will be useful for those who is going to appear for job or opting for higher studies. I have been associated with core chemical engineering activities, particularly research and development activities. Also, I had been in several selection committees for many years and hence I am very much aware the type of questions being asked during interview. Generally, questions are tailor-made and it is simple because candidates are in some stress and due to interview pressure, and many of the candidates are unable to perform well. And in interview, generally, they look for fundamentals and how the candidate attempts a particular questions. Many questions arises from the answers whatever candidate gives happening. My objective here to posting such video here is to share my knowledge whatever I have gained during my career, and so that someone get benefited from it. Since I am retired and during my spare time I make such video and try to post so that somebody get benefited from it. In future I will be keep on posting such video on some other subject also. So let us go through some typical questions on mass transfer operation. And before starting to question and answer part, let me describe about the figures shown here. Uh, all are mass transfer equipment, and this is a distillation column, and remaining are solvent extraction equipment. This is mixer settler, and this is a RDC, rotating disc contactor. This is centrifugal extractor. This is again a mixer settler. This is any mixing vessel, and this is a Taylor Quate column. So mixer settler and centrifugal extractors are stage-wise devices, whereas this RDC and Taylor Quate is a differential equipment. What is equilibrium relation? And shown in figure, three equilibrium line A, B, and C. What they represent? What is the physical significance of this? So, equilibrium characteristic of the system establishes ultimate separation possible or ultimate conversion possible. It also provides a correlation for finding out the composition of a component between two phases, and further transfer of a component from one phase to the another phase depends upon departure from equilibrium. So as per this figure, straight line equilibrium curve represents a dilute concentration system, whereas A and C represent any other system. Let us see that this so two cases represented here. So we see here in this case, for a small change in concentration in X phase, there is a large change in concentration in Y phase. So which indicates that uh, uh, X phase offers more resistance to mass transfer than the Y phase. Uh, if intensity of mixing in X phase is increased, so there will be increase in mass transfer rate. Uh, Oppositely, uh, as per this figure, uh, uh, Y phase offers more resistance to mass transfer, and if mixing intensity is increased in Y phase, so there is a possibility that mass transfer rate will be increased. Now, another question in this regard is that suppose you have equilibrium line
for a component A in a binary mixture A and B. So if the equilibrium curve nature is like this for component A, then what is the equilibrium curve shape for the component B? Uh, so this is a food for thought, and you have to think what is the answer. And generally, that equilibrium curves are obtained from experimental, and these experimental data are correlated by any other relation, empirical relation or theoretical relation, or in terms of graph. Describe significance of HTTP, HTU, and NTU. HTTP is the height equivalent to a theoretical stage, that is, height of differential column required to achieve same separation as in one theoretical stage. It is measure of separation performance of a column. Smaller the value of HTTP, better is the performance of the separation column. HTTP is determined experimentally, and its value depends upon types of packing, flow rate of individual phases, and physical property of the system. The method of using HTTP for designing of a uh, column height uh, is obsolete, and because large amount of experimental data are required in order to correlate HTTP. This is the expression for height estimation. Everybody must be aware of that, and this expression is obtained from mass balance across the differential column, and this is the STU, height of transfer unit. This based on X phase, and this is the NTU, uh, number of transfer unit based on X phase. HTU is a measure of difficulty of separation, whereas NTU is a measure of degree of separation. Height of the column estimated above by above relation is applicable only for plug flow condition, and if any channeling or any kind of entrainment or non-ideal behavior um, is happening inside the column, so this expression will not give correct height. So an extra term for non-ideal behavior has to be added in order to calculate correct height. Normally, most of the cases, uh, this inlet composition and outlet composition of a gas uh, uh, will be known, and this inlet composition of liquid for absorbent also will be known. So only things unknown is liquid flow rate. So generally question how will be that, how to estimate liquid flow rate. So for that, if you consider this figure, this is equilibrium curve, and this is a point known to me or then known to us, and from this point with different slope. The slope of the line is given by L by G. So many operating lines can be drawn through this point with different slope. The line which touches the equilibrium uh, is representing L by G minimum. Once L by G minimum is known, so then actual L by G is taken 1.2 to 1.5 times of L by G minimum. Otherwise, from this relation also L by G minimum is can be calculated provided equilibrium relations are known. So this is obtained from overall material balance. Now, should equilibrium line pass through the origin or not? I have noticed in interview at least 20 to 30% of the candidates are confused whether the equilibrium line should pass through the origin or not. So answer is that equilibrium line should pass through the origin. Uh, how the solubility of gases are determined in liquid or any other electrolyte solution. So solubility of gas is in liquid is obtained by Henry law equation, and here K is the Henry law constant, and its value depends upon temperature and temperature dependency of Henry log constant is given by one top equation, and if Henry log constant at any temperature is known, so at different temperature Henry log constant can be obtained by integrating this relation, provided this heat of solution is known to you. And in most of the cases, this heat of the solution is negative. Solubility of gas in electrolyte solution is determined by this relation, which is called Sechenov equation, and K is the Sechenov constant. Sw is the solubility of gas in water. S is the solubility of gas in electrolyte solution, and I is ionic strength, which is given by this relation. Ci is molar concentration of ith ith ion. Z is the valency of ith ion. K is given by this relation. I plus contribution from positive ion, I minus contribution from negative ion, Ig contribution from gas. Values of these parameters are provided in literature. These are all called salting parameters. Define stage efficiency and point out difference between stage-wise contactors and differential contactor. In a stage, two phases are brought into intimate contact with each other, and after the mass transfer, the phases are separated from each other. If the living streams are in equilibrium, and then the stage is said to be a theoretical stage or ideal stage, and the Murphy efficiency based on X phase is given by this. Murphy efficiency based on Y phase is given by this. And further, to understand the efficiency concept, so from this figure, this is the equilibrium curve, this is the operating line, and uh, this is the actual stage, and this is the theoretical stage. So Murphy's efficiency based on x phase is given by this distance divided by total distance. Similarly, Murphy efficiency based on y phase is given by this distance divided by total distance. So this is given by this expression. Now, the difference between uh, stage-wise and differential contactor. In stage-wise contactor, two phases are separated from each other at every stage, whereas two phases are separated at the end in differential contactor. And further, this uh, the living streams in a stage are assumed to be in equilibrium, whereas in differential contactor, two phases never reach equilibrium. Uh, and In stage-wise conductor, floor area requirement is high. Hold up of the solution is also very high. The residence time also is very high. So steady state reaching time is also high. In differential contactor, this hold up of the solution is small. Residence time also is small, and floor area requirement is small. But headroom, height of the building is very high. That is the requirement. For determination of mass transfer coefficient, generally we use empirical relation as Sherwood number as a function of Reynolds number and Smith number. So, what is the theory behind it? How it has arrived it? If you see from penetration theory, mass transfer coefficient is given by this relation, where Te is the exposure time, and exposure time can be replaced in terms of U max divided by L, and this is further multiplied by L by dA, so resulting this equation. And after that, when U max is replaced by this, so finally we get this expression, and this is known as a Piclet number. Further, Piclet number is can be written in terms of Reynolds number and Smith number. So now we see that Sherwood number is a function of Reynolds number and Smith number. Now question is what is flooding and channeling in a PAT column, and what is their effect, and how the flooding velocity is estimated. So this answer of this question can be found in any textbook. I am not going to discuss it here. And further question is what is the guideline for fixing the length and diameter of the column? What is the ratio should be taken for optimum condition? So general thumb rule is L by D ratio should be between 6 to 10 times in order to permit a better distribution of liquid phase and gas phase in order to avoid channeling. So L by D ratio should be between 6 to 10 times. Uh, Another question is that what is called superficial velocity, how to determine actual velocity if superficial velocity is known in a PAT column. So this also one can get the answer from any book. I am not going to discuss it. And further, the question is what is the function of mass transfer equipment? So function of mass transfer equipment is to provide turbulence and sufficient interfacial area and also facilitate counter current flow. Generally, mass transfer equipments are operated in a counter current condition. Choice of separation method, there are many factors, and a chemical engineer is faced with many options, choosing a various separation method available to him. So basic factors to be considered are physical state and physical property of the feed material. So that is the deciding factor. Second is that the simplicity of operation and previous experience of designing and operating a separation process. So that is should be taken into consideration. And third one is maintenance point of view. It should require minimum amount of maintenance. And fourth one is cost. Its cost also should be minimum. But what happens sometimes, uh, uh, the process cost, if it is minimum but is not simple to operate it, and also requires frequent maintenance. So in that case, cheap minimum cost process is discarded for this consideration. uh, Last question is that reaching steady state time. Uh, uh, Generally, when we do any experiment or operate any process equipment, so one has to some idea when your equipment or when your experiment is reaching steady state condition. So then only that product concentration will meet at steady state condition only. Before that, it is a transient state, and your product concentration will be far from your requirement. So one has to have some idea about the reaching steady state condition. General thumb rule is that uh, 5 to 6 times of residence time will be required to reach steady state any process equipment or any experimental study. So uh, uh, e- e- residence time is given by volume divided by volumetric flow rate. So 5 to 6 volume change is necessary in order to reach steady state condition. For example, uh, suppose your process equipment volume is 100 liter, so roughly 5 to 600 liters of solution has to be passed through the equipment or process equipment in order to reach equilibrium condition. That's all today, and thank you very much for paying attention. In coming in next video, uh, I will be providing some more questions and answers. So, thank you again.